Okay, so we continue with example 1. Okay, so in example 1, we're taught to resolve 11 minus 3x over x squared plus 2x minus 3 into partial fractions. Okay, so now let's solve. So we have 11 minus 3x, okay, 11 minus 3x over x squared plus 2x minus 3. Okay. So what we first do is, remember, we have to factorize the denominator. So we have x squared plus 2x minus 3. The sum here is 2 and the product is minus 3. So you have 2 and 1. Wait. The sum is 2. No. So this should be a 3 and a 1, but we put the minus on the 1, so that 3 plus 1 gives us a 2. 3 multiplied by minus 1 gives us minus 3. Okay, so our denominator therefore becomes 2x squared minus x plus 3x minus 3. So x minus 1 plus 3 x minus 1. So this then gives you x minus 1 and x plus 3. So this is the value that we get when we factorize our denominator. So we now put in 11 minus 3x and we put our denominator there. Okay, so as you can see from our denominator, the highest power of x is 1. That is why we call them linear factors. The highest power of x is 1. So when we have such factors, what we can do is say this should give us a x minus 1 plus b x plus 3. When we make into a single fraction, we have x minus 1, x plus 3. A into there, we have a multiplied by x plus 3 plus b multiplied by x minus 1. Okay, so this is what we have. Then we have this side, we have 11 over 3x over x minus 1 and x plus 3. So what we notice here is that the denominators are the same. Therefore, even the numerators should be the same. So we have 11 minus 3x is equals to a x minus x plus 3 plus b x minus 1. So then what remains is to determine a and b. Okay, so here what you use are the values of x in the brackets. So you first get your x plus 3 and you equate it to 0. This implies that x is equal to what? Minus 3. Then you say that when x is equal to minus 3, what do we get? When x is equal to minus 3, this one you know, it will be what? 0. Okay. So x will be minus 3. Let's replace. 11 minus 3 is equals to, there you have 0, b minus 3 minus 1. So this is 3 multiplied by 3, 9. So you have a plus there. 11 plus 9 gives you 20 is equals to minus 3 minus 1, 4. Actually it's minus 4. Minus 4b. When you divide by b, divide by minus 4, divide by minus 4, you have b equal to minus 5. So this is not it. We need to find the value of a as well. So remember, we had in brackets x plus 3 and x minus 1. So we're going to use this one now and equate it to 0. So we have x minus 1 equal to 0. This implies that x is equal to what? 1. So you say when x is equal to 1, what do we have? We know we have 11 minus 3x is equals to a, x plus 3 plus b, x minus 1. So let us now put 1 there. 11 minus 3 multiplied by 1 is equals to a, 1 plus 3. And here, when you put a 1, 1 minus 1 gives you 0. So we have nothing there. Okay, so this gives us 11 minus 3, and that's what? 8. 8 is equals to 4a. Divide by 4, divide by 4, and you have a is equal to what? 2. Now that you know your a is 2 and your b is minus 5, you can just replace now. Remember, 11 over 3x, x squared minus 2x minus 3 is equal to a over x minus 3 a over x minus 1, right? Yeah. A over x minus 1 plus b over x plus 3. Our a was what? 2. X minus 1. And our b is a minus, so we can put a minus there. 5 over what? X plus 3. And there we have it. We have resolved our given function into partial fractions. Okay. So in the second example, we need to resolve 2x squared minus 9x minus 35 over x plus 1, x minus 2, x plus 3. Okay, so this is the long one. What you notice here is that the highest power of x is x multiplied by x multiplied by x is x to the power 3. And the numerator is x to the power 2. So this is an okay scenario because the power of the numerator is less than the power of the denominator. Okay, so therefore, this is just equal to a over what? X plus 1 plus b over x minus 2 plus c over x plus 3. Make it to a common denominator. So a will be multiplying by x minus 2 and x plus 3, and b will be multiplying x plus 1 and x plus 3, and c get x plus 1 and x minus 2. Oh, okay. So again, the numerator is same as the denominator, so we can equate. Okay. So now we're going to let here, if we equate to 0, that means x will be 2. So we let or you can say when x is equal to 2, when x is equal to 2, this will be 0, this will also be 0. So that means we just remain with the b terms. Therefore, when x is 2, you have 2 there. On the numerator, you have 2 multiplied by 2 squared minus 9 multiplied by 2 minus 35. Okay? This should be equal to only the b here. Here 2 plus 1, 3. 2 plus 5. 2 plus 3 is 5. So you have 3 multiplied by 5, which gives you 15. 15 what? B. So the answer here when you compute this is minus 45. Is equals to 15b. This just implies that b is equals to minus 3. Okay. So again, we have solved for b. Let's choose another scenario. Let's have x plus 3 equal to 0. That means our x will be what? Minus 3. So when x is equal to minus 3, this will be 0. This will be 0. Only the c will remain. Okay, so then we have 2 multiplied by minus. Take note, this is when x is equal to minus 3. Minus 3 squared minus 9 minus 3 minus 35. Only the c remains. C multiplied by 2 multiplied by 5. Then this gives 10 is equal to 10c, implying that c is equal to 1. Okay, so the last case is when x is equal to what? When x is equal to minus 1. Okay, so when x is equal to minus 1, this will be here the b will be 0, and here you have a 0, so only the a will remain. Therefore, you have 2 multiplied by minus 1 squared minus 9 divided by minus 1 minus 35 is equals to a multiplied by minus 3 and 2. So minus 24 is equals to minus 6a, implying that a is equals to 4. Now that you have all the values for a, b, and c, we can now just replace, and we have that 2x squared minus 9x minus 35 over x plus 1, x minus 2, x plus 3, just equal to a, which is 4, over x plus 1 minus 3 over x minus 2 plus 1 x plus 3. Okay, so you will do the other example in the module where you first have to divide, because the power in the denominator is greater than the power in the power is actually equal, so you don't want to have that case. Okay, so